Welcome. This video covers the ggplot2 package for creating plots in R. We are looking at data and trying to figure out how to make meaningful summaries of it. And the first thing we said is, hey, we got to understand which kind of data we have. Is it categorical? Is it numeric? And then we were able to summarize it numerically. What we're going to do in this next section is look at how to do the same kinds of summaries, but through graphs. And graphs are oftentimes a lot easier for people to understand. There are a couple different ways that you can create graphs in R, and all of them are great. There's the base R functionality, so the built-in functions that can do plotting like hist and plot itself. Base R plots are fantastic. They look nice. You can customize them as much as you want, but the main issue with using those is that you have to do a lot of the tedious work yourself. If you want to create a legend, you have to manually create the legend and add it to your plot. If you want to color the points in your plot, you have to manually color the points. So it's just not as easy to use. It's not as user-friendly as some of these other packages. There's a lattice package as well that can do lots and lots of different plots. It's a great package to do multiple plots, but not part of the tidyverse. And so what we're going to look at is using the ggplot2 package. And this is sort of part of the tidyverse. It doesn't exactly follow the same syntax because it was made by the same folks, but it was made just before the tidyverse really took off. And so it uses plus signs instead of chaining. And so it's not exactly in the same syntax, but it is very, very, very widely used. And there's lots of great resources and examples of people using it. Eventually, there's going to be a package called ggviz that will take over for ggplot2, but that's still a ways off in the distance. And that package should use the exact same syntax. All right, let's try to figure out how ggplot2 works. Well, there's this lovely cheat sheet that's going to be really handy for us. We'll take a look at that in just a minute. But the idea is essentially that you are going to create a base plotting instance using the ggplot function. And this just says, hey, I'm going to create a plot, and usually you'll specify some things like the data frame or tibble that you want to work on. And from there, what you'll do is you'll add layers to the plot. And the layers are what actually creates visualization on that base plotting instance. Let's look at the cheat sheet here to get an idea of what we're talking about. So this is a cheat sheet for ggplot2 that RStudio has on its website. And let's just jump down here to the one variable section. And we should be able to hopefully get something out of this. They're saying that if you have one variable that you want to summarize with a plot, and it's a continuous variable, which is their way of saying numeric, here is how you might do it. You're going to create a base plotting object up here. So what we're doing is saying, I want to create a base plotting object, and I'm specifying the data set within here. So MPG is a data set. And then I'm going to specify some aesthetics of the plot. And so aesthetics are just things like the X variable, the Y variable, the coloring of points. And what it is by default, if you don't specify which one this is going to specify your X variable first. So this is saying my X variable here is going to be the highway variable. And then here are the different layers that you might add to that. Again, this is just creating a base plotting instance. It's essentially saying, I want to use this data set, and here's some aesthetics that are going to be used for the plot. So now I know what to put on my x-axis. I don't know what visualization to put on yet, but I know that highway is going to go across the x-axis. And then what you do is you take that base plotting instance and you use a plus sign, and then you add a particular geom layer. Here are the common geom layers that you would add for a continuous variable. So an area plot, a density plot, dot plot, frequency plot, histogram, and QQ plot. So the one that people are most familiar with probably is a histogram. And so here are the different aesthetics that you will commonly specify for a histogram. X is really the only one that you need, but you could specify things like color, and that'll change the coloring of the outside of your bars. The fill will change the inside of the bar, and you're able to really customize your plot based off of these different aesthetics. And so within these layers that you're going to put here, you can also call the AES function within there and specify other aspects that are specific to this particular layer of your plot. And what's nice is that you can actually overlay multiple things on the same plot. So if I wanted to put a histogram, I could do that, and then I could overlay a density plot on top of that. And it's really easy to do with this type of system. Now we're going to start with one discrete variable, and so there's only really one common way to describe what they call discrete is what we call categorical. So we're going to look at bar plots. So we're going to use the geom bar layer and specify which variable we want to have across the x-axis, which should be a categorical variable. And then here are the other common things that we might assign from the data set to certain aesthetics within our plot itself. So again, that's the big idea. Create a base plotting instance. We specify usually the data set and maybe some global aesthetics there. And then we're going to call layers and add them to the plot. And we'll be able to customize what those look like. And ggplot will automatically add legends and do all of that tedious stuff for us. Okay. Again, just to go through that idea, we create our base plotting instance, we add layers to it, and within those layers, we are able to modify the mapping arguments using the AES function or aesthetic function. What that means is we're able to take variables from our data set and map them to different attributes of the plot. Then you can add things like a title layer. You can do what's called faceting, which just creates lots and lots of plots of the same type. So we're going to see how useful and how easy it is to build lots of sort of publication-ready graphs using ggplot2. But let's get started with an example. How do we create a basic bar plot? So we want to summarize a categorical variable. We said we want to just describe how often each one of the categories shows up. Numerically, we do that with a table. Graphically, we do that with a bar plot. And what we're going to do is take a ggplot instance and then add a geom_bar layer to it. Across the x-axis, of course, what we want is our categories. And we can specify the x variable using our AES function. So if we start with the ggplot function, we say ggplot data Titanic data. AES, I want my x variable to be survived, and I just put that in my console. What I get out is this, an empty graph. I have not added a geom layer yet, or a stat layer, and all this has done is set up a plotting instance for us. It knows that survived goes on the x-axis, so that's down here, but other than that, we don't have anything specified. If we add a geom_bar layer, which is easily done by just doing a plus sign and then adding that layer, this will now say, oh, okay, geom_bar knows that what I want to do is count the number of times each one of the survived categories showed up. And I want to make bars based off of that. Very easy way to create a bar plot. How you generally create your plots using ggplot is to create a base object that you then add layers to. For instance, oftentimes you saw on the cheat sheet they use like C. You might create a base object called G that is just the call to ggplot. And then what you do is you just add layers to that. And so if you're going to create multiple plots, you could do another one G plus something else. This just gives us an easy way to create plots and sort of make sense of it. Again, the AES, the aesthetics that we assign here are going to be what we refer to as global aesthetics, which just means that these are going to be the aesthetics assigned for every subsequent layer that we add, unless we override them on that layer. Now, if we looked at that bar plot that we just made, it's kind of suboptimal, right? We have a continuous scale down here, right? And that's not ideal because this continuous scale is really representing a categorical variable, right? This just has two values, 0 and 1, or did not survive and survived. So there's a couple ways that we can fix that. We could fix it with additional layers. So we could add an layer that changes the x-axis values. And that's fine to do, but it's actually easier to do some of this stuff prior to doing the plotting. So we can actually just change the type of variable that we're dealing with, and it comes out looking much nicer on the plot itself. And this leads us to the idea of factors. We did look at factors just very briefly in one of the previous videos, but this time we'll dive a little bit further into them. If you remember this survived variable, since it's coded as 0 and 1, it's read in as a numeric variable. It's truly not numeric, but it's read in as numeric. R doesn't know the difference. And so what we can do to make our plots a lot better is to coerce this thing or create a factored version of that variable. And so factors are a special class of a character vector that has a levels attribute to it. And what these levels do is they define all of the possible values that this variable can take on. And they're fantastic for variables that represent things like a day, because there's only ever 7 days that could happen. There's never going to be another day that we would have to worry about adding in. So a factor is great because I never have to worry about getting new levels for this variable. Factor works perfect for day. If you have a variable like name, it's not great to have that as a factor because you could get somebody who has a different name and then you can't assign that value to the variable unless you add it to the levels first. So it gets a little bit difficult when you're dealing with variables like that. Okay, well, why do we prefer these factor variables? Again, they're great for plotting, and since there's this levels attribute that defines all of the values it can take on, you can order those things and actually change the ordering in which things show up within your plot. Not only that, but you can give it much nicer labels as well. So a very easy way to do both of those at once. Let's figure out how to do that. We can create a factored version of survived by using the as.factor function. As.factor says just take this variable and coerce it to a factor. And if we look at the structure of this newly created variable, mySurvived, that we just made here, this is a factor with two levels, 0 and 1. The actual values that they're stored as are 1 and 2, but 1 is mapped to 0 and 2 is mapped to 1. And so there's this function called levels that allows us to investigate the values that this factor variable can take on. And we see here that we can only take on 0 and 1. So if we try to add something like 5, so if I try to replace the first element of the mySurvived vector with a 5, it's going to say, no, I can't do that. That is not one of the levels that you have specified up here. So again, this is one of the good things about factors, but also bad things. If you have a variable that only takes on a couple values, it's really great. If you don't, you shouldn't use them as factors generally. Now, what else is useful about these things being factors is that you can change the labeling very easily and make it much, and you can also rearrange them as well. For instance, I can overwrite the levels. Remember, the levels were 0 and 1. So 0 represented they did not survive, and 1 represented they did. Well, I can overwrite the levels to be more descriptive. I can say died and survived as the values. And now say I make a one-way contingency table, I get a much better looking result than 0s and 1s. Okay. Again, you can also change the ordering, which is quite nice. And so you can do that down here. So we're going to create that same variable. We're going to do mySurvived, but this time we're going to use the factor function rather than as.factor. As.factor lets R figure out how to assign the levels, but factor, you can assign them yourself. So here I'm going to say factor, mySurvived, and then the levels are going to be survived and died. So I'm going to specify those myself rather than let R assign them as 0 and 1. And what this does is this allows me to then have these in a different order. So survived comes before died in this particular case. Okay, so that's the little discussion we needed to have about factors. It's really useful to have them in plotting, so we're going to work with them when we have categorical variables. We're going to go ahead and create a couple other factor variables. I'm not going to worry too much about the ordering. I'm just going to let R figure that out, and then I'll rename them. So we're going to create a myEmbarked variable from the embarked variable, and we're going to just rename the levels appropriately. We had the C, Q, and S before. Now we have better descriptive labels. And then what I'm going to do is drop any NA values from the survive variable, the sex variable, which was male and female in this case, and myEmbarked variable we just created. This makes us have a new data set where we don't have to worry about any NAs for these categorical variables. Now, we're going to create the same exact bar plot, but use the factored version of the variable survived. So rather than having survived here, I have mySurvived. Now you can see that we get a much better looking x-axis label. We have survived and died, and we don't have other numeric values floating around. Okay, so let's try to customize this bar plot. What are the other things that we might change about this? Well, remember that the AES function defines the attributes of your plot. Basically, you're going to use this function anytime you want to take a variable from your data set and assign it to some attribute of your plot. And again, the cheat sheet is going to give the most common properties for a particular geome. If we look here, these are the most common properties that you would change for a bar plot. So I have those listed here. This is the basic way that you would create a bar plot and the things that you would consider changing. Let's first look at a stacked bar plot, which can be created using that fill aesthetic. And again, what's great about ggplot2 is it will automatically do things like create legends, figure out which colors you should use, and it just takes a lot of the hassle off of you. So we're going to create our base plotting instance. We're going to say ggplot, this is the data we want to use, and these are the aesthetics that I want to use for any subsequent layers. And now I'm just going to take that base plotting instance and I'm going to add a bar layer. And so this is what that plot looks like. You can see now that the bars themselves are filled, the coloring is filled by the my embarked variable. So our ggplot2 automatically picked the colors and created the label for us. Sorry, the legend for us, which is fantastic. Okay, let's talk a little bit more about the aesthetics that we're assigning. So I've been talking a little bit about the idea of the global aesthetics that we can assign in the ggplot call itself, and local aesthetics that you can apply on a particular layer. And so, for instance, here are a couple examples of global and local settings and mixed. In this first call, we are assigning everything at the global level. So everything is being assigned here at the ggplot call. And so these are going to be these settings for all subsequent layers unless we override them locally. Here, I'm assigning some of these things globally, but then I'm also assigning some of them locally. So this is only going to apply for this particular layer. If I added a second layer after this, it's not going to have my X variable be my survived. And then here I'm doing everything locally. So I'm just creating a base plotting instance with nothing, and then I'm using the geom bar call to specify the data set and the variables themselves. So you can do it in both ways. In this case, let's go ahead and try to improve our plot by adding some extra layers. We'll create our base plotting instance where we are just specifying the data set. We'll specify a geom bar layer on top of that with the X and the fill variables. And then we're going to add in a labs layer. And this labs layer lets us change what we see on our X-axis label, what we see on our title, and a few other things. In this case, we're going to change our X-axis label using a quoted string, the title using a quoted string, and the fill legend using a quoted string as well. And that looks a little bit nicer than what we had before. It's also very easy to then take your plot and say, turn it sideways. All we need to do is add an appropriate level. We're going to take the same code we had before and then add a layer. Sorry, I said level. We've got to add a layer. We're going to add a layer called a chord flip layer. So this is going to flip my coordinates. My X and Y are going to flip, and now I get a horizontal bar plot. Okay, and so that's the basics of how you would do ggplot plots. You will create your base plotting instance, and then you're going to add layers. Well, I did mention before that you could do geom layers or stat layers. So let's just chat briefly about what the difference between those are. If you look in the help for geom bar, you can actually see within here there is a stat argument. And so this is the default stat that is going to be calculated by geom bar to create that plot. And so there's actually a corresponding stat layer that can be used instead of a geom layer if you wanted to. So you can get an equivalent plot using geom bar or stat underscore count. Either one will do bar plots for you. Most people do not use the stat layers, but every once in a while you will see them floating around. The other reason that I bring this up is because you can modify that stat that you are actually using. Oftentimes what you're given or what you have instead of the raw data might be a summary table. For instance, this would be a summary contingency table about the same data set. So we already have the counts, the heights that we want for our bars. How do we take those counts and put them on a bar plot whenever R doesn't need to do the counting for us? Well, what we do is we just utilize the stat equal identity argument to the geom bar call. So here we are. We're going to create our base plotting instance, geom bar, and then we're going to say within geom bar that the stat that should be used is the identity stat. And then we're going to specify our X, Y, and fill variables. So in this case, we had to add the Y variable that we wanted to assign since we were using this identity part. The other interesting thing here is that this stat input does not go within the aesthetic. So you only put variables in the aesthetic you only put aesthetics in here, the things that you want to change in here, if it's a variable that you are mapping to an aesthetic, generally speaking. Things that you are not involving variables from your data set with just go outside of here. So if I just wanted to change the full coloring of these bars, and I didn't want to fill them by sex, I could put fill equal blue outside of the AES, and it would just fill the bars with blue. So again, AES only has variables that you're mapping to aesthetics in there. Let's finish our discussion of bar plots and the things we might want to do with them. We could also create side-by-side bar plots. Those are pretty common. How we do that is we just change the position aesthetic for our plot. So we can do dodge for the position aesthetic to get a side-by-side bar plot rather than stacked bar plot. So by default, this is the setting for position on a bar plot. So when we do fill, it's going to fill them and stack them on top of each other. But if we want to change that, we can use position and set it equal to dodge. Here's a different way I'm going to specify this plot. I'm going to use global options up here, global aesthetics. And then in my geom bar layer, again, this does not depend on a variable within my dataset, so it does not need to go in an AES. I'm going to do position equal dodge. And so rather than stacking, these things are going to dodge or miss each other and go side by side. Personally, that's my favorite kind of bar plot. And then one other type of bar plot that you might use, especially when you have something like Likert scale data, would be to use the position equal fill. And this just makes all of the bars have the exact same height, but then they fill by a different variable. All you got to do is change position equal fill, and that's what you'll get out of that. The big issue with this is that you lose some of the information about the sample sizes between the groups. So it's really useful whenever you have equal group sizes. All right, let's jump into R and do a couple quick bar plots. Back into R we go. We created some contingency tables up above, and so we might want to just go ahead and use those contingency tables to create bar plots. We're going to use this cancer data still, and we had this Menno variable and grade variable. So we were able to create a contingency table based off of those. Let's just remake this in bar plot form. So we'll come on down here, add a new section, ggplot2 for bar plots. Go ahead and put in a code chunk. And now we're going to create a base plotting instance with the ggplot function, give it the data that we want, which is our cancer data. And we can specify the aesthetic here. I know I want my X variable to be one of those two. Let's make it Menno. And then I'm going to fill my bars based off of the, let's go with the, the grade variable. And again, if I run this just by itself, this just creates a basic setup for a plot, but it doesn't actually add anything to it. So I'm going to do plus, well, actually we'll do a base plotting instance, save it as G. Then we'll do G plus geom bar. And since we specified Menno and fill here, we'll get a stacked bar plot. So we got an issue here. This did not fill correctly because grade is a numeric variable, I believe. Let's look at the structure of our cancer data. Look at this. If I remember correctly, yes. So grade is read in as a double. So an easy way to fix this would just be, at this point, just as.factor that grade variable. And then G plus geom bar. Now that will fill that in. Of course, that makes this kind of ugly. We can change that on the back end, or we could go back and change the levels of this factor and change the name of it. It's probably the easiest way to do it. But just to show you you're capable of doing it here, we'll go ahead and add a labs layer. And the easiest way to figure out what to add from labs is to look at the cheat sheet. But there's, if we just do fill equal, we can do grade. And that'll make that a little bit better. So now we have a little bit nicer looking stacked bar plot. You can also change the values that the legend has in it, but we won't take the time to do that here. Okay, welcome to the wonderful world of ggplot2. It does have a bit of a learning curve to it, but we're going to go through a couple more plots in the next couple videos, and then we'll talk about faceting as well and other themes and really neat stuff that you can do to customize your plots and make them look really nice.